Lecture 11.4, Area of Regular Polygons. The area of an equilateral triangle is going to be equal to 1/4 of the side squared times the square root of 3. We're going to use that with a lot of our area of regular polygons because we can break down polygons into sets of triangles, and a lot of polygons can be broken down into multiple sets of equilateral triangles. Alright, so let's find the area of an equilateral triangle with 8-inch side lengths. So we're going to use our formula. Area equals 1/4 times our side squared, which is 8 squared, times the square root of 3. That's going to equal 16 square roots of 3. Finding the area of a regular polygon. A regular polygon is going to be equal to 1/2 of the apothem, which is A. It's the vertical line from the center of our polygon perpendicular to one of the bases of that polygon, times P, which is the perimeter. And because the apothem is a perpendicular line, we know it's going to form right triangles with the radius and the half of the side and the apothem. So we're going to be able to use a lot of our right triangle trigonometry, our sine, cosine, and tangent. Alright, if we are asked to find the area of a pentagon with a radius of 4, we know pentagon is a 5-sided figure, and it's broken down into 5 triangles then, all with 2 equal sides of 4. And we can find the interior angle of each one of those triangles by taking 360 and dividing by 5 to get 72. So then we know our angle that we're going to use with our right triangle is going to be half of that, so it's going to be 36. We'll use that information here. So we still have a radius of 4. We need to find x and y so that we can get our apothem, which would be x, and we can use y to find our perimeter. So we know the cosine of x, or the cosine of 36, is going to equal x over 4. So then solving for x, we'd multiply both sides by 4. So x is going to equal 4 times the cosine of 36. We also know that the sine of 36 is going to equal y over 4. We multiply both sides by 4. Y is going to equal 4 times the sine of 36. Now we know to find the perimeter of a pentagon. First off, we know that the apothem split our base into 2 equal parts. So if we multiply y by 2, we're going to have the length of the base of our pentagon. If we multiply that by 5, then we're going to have the total perimeter. We know our apothem is x, and 2 times y is going to equal one side, like I was just saying. The perimeter has all 5 sides, so we'll multiply 4 times the sine of 36 by 2 and then by 5. Or in other words, our perimeter is going to equal 40 times the sine of 36. Then we put all of that information together. We know our apothem is 4 times the cosine of 36. Our perimeter is 40 times the sine of 36. So then the area is going to equal 1/2 of the apothem times the perimeter. So we're going to have 1/2 of 4 cosine of 36 times 40 sine of 36, which is going to equal approximately 38.04. Finding the area of an octagon with radius 7. We know, again, an octagon is going to have 8 sides, so we can break it down into 8 triangles of equal area. Right? And we know the radius is 7, which is also our hypotenuse. If we divide our 360 by 8, we realize that the angle there that is being split is 45. So half of that 45 is going to be 22.5. So we use this triangle to help us find our apothem and perimeter. So we know the cosine of 22.5 is going to give us x over 7. Multiply by 7. X is going to be equal to 7 cosine of 22.5. Same thing with sine. Sine of 22.5 is going to equal y over 7. Multiply both sides by 7. Y is going to equal 7 times the sine of 22.5. Again, we know x is our apothem, and y is going to be half of one side of our octagon. So we multiply y by 2 and then by 8 to get our perimeter. So our perimeter is going to end up being 112 times the sine of 22.5. We plug that all into our formula. We know our area is going to equal 1/2 of the apothem times the perimeter. So we take our apothem A, multiply by our perimeter, and by 1/2. So our area is going to equal 1/2 of 7 times the cosine of 22.5 times 112 times the sine of 22.5, and that's going to equal approximately 138.59 for an area. Hexagons are going to end up being our favorite shape. Those are our friends. Because hexagons can be broken down into 6 equilateral triangles. So we can use our equilateral triangle formula to find the area of one of them and then just multiply it by 6. So if we're going to find the area of a hexagon with side length 6, we're going to use our formula. The area of an equilateral triangle is equal to 1/4 times side squared times the square root of 3. So all we need to do is plug in our side length of 6 for side squared. So we're going to have 1/4 of 6 squared times the square root of 3 to find the area of one of those equilateral triangles. And then we just multiply that number by 6 because there's going to be 6 of those equilateral triangles throughout this hexagon. So we're going to have 6 times 1/4 times 36 times the square root of 3, which is going to be 54 square roots of 3, or approximately 93.537. Find the area of a decagon with a radius equal to 6 and a side length of 4. We know a decagon is going to have 10 sides, and if the side length is 4, when we bring the apothem to the side length, it's going to split that in half. So one of the sides of our little triangle is going to be equal to 2. The hypotenuse is always our radius, which is equal to 6. So we have 2 sides of our right triangle here. So we can use the Pythagorean theorem to find x. We know 2 squared plus x squared is going to equal 6 squared. Solving that for x then, we're going to get x equal to 4 times the square root of 2. We know x is equal to our apothem. So our apothem equals 4 times the square root of 2. If a decagon has 10 sides, with a side length of 4, we know the perimeter is going to be that side length 4 times 10. So our perimeter is going to equal 40. We plug that into our area of regular polygons formula. So we know 1/2 of 40 times 4 square roots of 2 is going to be our area. So we're going to have 80 square roots of 2, which is approximately 113.13. Finding the area of a regular dodecagon with a radius of 6. We know a dodecagon has 12 sides. So the central angle of the triangle we form is going to end up having 360 degrees divided by 12, which would be 30. So that angle is going to be 30 degrees, but when we split that in half with the apothem, that's going to be down to a 15-degree angle, creating our triangle here. So we use that to find our apothem, which is x, and half of a side length, which would be y. So we know the cosine of 15 degrees is going to equal x over 6. So we multiply that by 6. We know our apothem, which is x, is going to equal 6 times the cosine of 15. We use that same idea to find y. We know the sine of 15 is going to equal y over 6. Multiply both sides by 6. Y is going to equal the sine of 15. but we know that y is just half of one of our sides. So we need to multiply that by 2, and we have 12 sides, so our perimeter is going to be, again, that multiplied by 12. So each side is going to be 12 sine of 115, and since we have 12 sides, we can multiply that by 12 to get our perimeter of 144 times the sine of 15. So then we just plug that into our area of polygons formula. We know the area is going to equal 1/2 of the apothem times the perimeter. So we're going to have 1/2 of 6 cosine of 15 times 144 sine of 15, which is going to be approximately 108. Here we're asked to find the area of a regular hexagon. We want it rounded to the nearest tenth, and we know that, well, hexagons are our friend. They're broken down into 6 equilateral triangles. So we can take our area of equilateral triangles formula, which would be 1/4 times side squared, which would be 7.5 squared, times the square root of 3. And we know there are 6 equilateral triangles in that hexagon, so we multiply that number by 6. And we plug that into our calculators, and we're going to get 146.1 for an area. Ignore that. Here we are asked to find the area of a regular pentagon rounded to the nearest tenth. We know pentagons, again, we're going to break them down into 5 equal triangles. They won't be equilateral, however. We know since they're 5 triangles, the central angle of our triangle here is going to be equal to 360 divided by 5, which is going to equal 72. So then half of that, when we drop our apothem down, is going to be equal to 36 degrees. So to find our apothem, we need to find the length of xz, which we can call little x. We're also going to need to find the perimeter, so we're going to need to find zy, which we'll call little y. So we know the cosine of 36 is going to equal x over 7, or x then is going to equal 7 times the cosine of 36. Similar logic, we're going to use sine to find y. We know sine of 36 is going to equal y over 7. So y is going to equal 7 times the sine of 36. But we know y is just half of one side length, so to find the whole side we need to multiply that by 2. So one side is going to equal 14 times the sine of 36. And we need to find the perimeter, which would be all 5 sides, so we need to multiply that by 5. So we're going to get 70 sine of 36 for our perimeter. And then we'll just multiply our perimeter times our apothem, which is 7 cosine of 36, and multiply that by 1/2 to find the area of our pentagon here, which is going to be 116.5. Finding the area of a shaded region. So to find the area of a shaded region, we need to take the area of the whole shape. We see a big circle there, and we need to subtract away the area of whatever shape is unshaded. So in our case, we're going to have the area of the circle minus the area of the polygon. We notice here that the radius is 4. The area of our circle is going to be pi r squared minus the area of the polygon, which is 1/2 our apothem times perimeter. So we know the area of the circle is going to be pi times 4 squared, or 16 pi. And since we have a hexagon here, we're going to have a 30-60 triangle with a hypotenuse of 4 to find our side length. So we know our area is going to equal 4, or 16 pi, like I said earlier, minus 1/2 times 2 square roots of 3 times 24. our apothem we know is going to be the long side of our 30, 60, 90 triangle here. So half of the small side would be half of the hypotenuse, which would be 2. The long side is always the small times the square root of 3, so that's where we get our 2 square roots of 3. Since the small side here was 2, we doubled that to get 4 for our side length and multiplied by 6 to get our 24 for our perimeter. So our area is going to be 16 pi minus 24 square roots of 3, which is approximately 8.696. 17, here we're asked to find the area of the shaded region. So we're going to need to find the area of the sector and subtract off the area of the triangle. Since they give us the arc length or the arc measure being 60, we know our central angle is 60, which means we have an equilateral triangle there. So we're going to find the area of the sector, which is the measure of arc AC over 360 times pi r squared minus 1/2 base times height. Again, since this was an since it's an isosceles triangle, we know with a 60-degree angle we can split that in half. It's going to be 30. So we have a 30, 60, 90 triangle again. So to find the height of that triangle is really just going to be where our x was, where we're used to finding the apothem. To find the base, we're just going to have to double the small side. We know the small side is always half of the hypotenuse, so that's going to be 4. The long side, or the height, in this triangle is going to be 4 times the square root of 3. So we end up with our arc measure, which is 60 over 360 times pi times 8 squared minus 1/2 of 8, which is our base, times 4 square roots of 3, which was our height. So our area is going to be 32 pi over 3 minus 16 square roots of 3. So our area is going to be 5.797. This ends the lecture for 11.4. Remember, we have a blog due tomorrow, and we'll be looking at your homework checks in class. Have a great day.